We actually did this project. It's originally a joke. So the idea is to use your genetic information to find your perfect match, so we can end up with a wedding ring on your.
23andUs now.
23andUs. Yeah, changed it. No, that doesn't. Goal, just hair or saliva samples in your first date. The tighter people think. Wouldn't it be great if there was a better way? So we created a service that optimizes genetic matches between potential partners, selecting the most compatible gene pool for helping smarter progenies. So the way it works right now, Sandeep made this nice form that accepts a 23andMe raw file. I'll go through more in detail what we did in the next couple slides, but we're using Plink. Plink actually will read in a 23andMe file. It will convert it to a VCF or a BIM/BAM file. Then we match, so we're using the 1,000 genomes data as the potential dating pool because all we have is Sandeep and I's 23andMe data. Anonymous. So, yeah, I'm sorry, two anonymous data sources. So we're just scoring your input file against 1,000 genomes. We created a magic formula that we'll describe in a minute. Yeah, we'll get to that. And then we create an avatar of your matches using variant data that's associated with physical characteristics. And you get to know genetic facts about them from some other variants that are associated with some other traits. And matches you to your anonymous 1,000 genomes. Do you want to talk about where you got the good and bad?
Yeah, so people have collected these, so based on the genome-wide association studies, people know of certain genetic markers associated to certain traits and the magnitude of risk factors that they, like, so effect size. And so they can be categorized as good or bad. So if you just click, so for example, these SNPs have been associated with younger, healthier kidney function, and the odds ratio or the effect is 2.4 based on whatever their control sample was. And then this would be low risk of arthritis, and then so the bad ones would be something that is associated with disease or a particular characteristic, and we know the genotype exactly. So we use this type of data to match partners based on their progeny. So you want your progeny to not have any bad characteristic, but you want them to have good ones. I guess you can start with that if you want. So basically, it's based on the Punnett square, right? So we know these frequencies of what to expect in the progeny, and then we add it to the magnitude of good or bad, and then we generate a total magic score. And based on the score, you're matched with the perfect person.
Any questions on our algorithm?
Wait, but surely the odds ratio is not the same between different states.
No normalization.
Let's move on.
The other thing we wanted to do is figure out the population that you and your match are part of, so we can make a more accurate avatar for the matches, since you're not allowed to upload profile pictures. So I use this program iAdmix, which was made by someone in UCLA. It basically just takes genotype data, so a list of RSIDs and the genotype. It uses the HapMap minor allele frequencies for each of the 7 or 8 different populations that are in HapMap, and then calculates your ancestry. So it outputs something, it outputs a bunch of stuff, but we get end up with something that looks like this, which is the 3-letter ancestry code along with the 0 to 1 fraction of associated ancestry for your input data file.
You could also put in 1,000 genome ancestry as the reference. So instead of just mapping it to 8 or 9, you can go even deeper in the ancestry. Because 1,000 genome has about 20 or 30 different ancestry groups.
Yeah.
But
I tried to
we
do
ended
that.
up- Yeah, we ended up using HapMap because
Yeah.
they provided the reference file in the right format and stuff.
Yeah.
But we tried though.
Yeah. And it was going to be hard to make 30 different avatars for, you know, Nigerian or Kenyan or something. So the facial, you want to talk about this? Okay. So our facial reconstruction was based on me avatars. Will actually made 280 of these using race, population, skin color, eye color, hair color, whether or not the chin has a dimple, eyebrow or a unibrow, and then gender. So we have all of these, and they're all tagged with the appropriate characteristics. And we also, do we have to? We also have variants that we found using Snipedia that are associated with these other things like hair color, variants that determine whether or not you have a chin dimple, if you have a unibrow. So we have all of these in a Python function. It just takes the your genotype file and scores you on all of these traits, and it just outputs your characteristics, and then we can look up the appropriate picture that's tagged with these characteristics, and we get your avatar. Yeah. See that? Yeah, I already said that. So, and then lastly, once you find your perfect match, we can predict what your child will look like. So this is just, we don't have this actually live working right now, but it's all scriptable, so this is all done using ImageMagick. So we can take your ancestry data, pick the appropriate avatars for each ancestry, and then blend all those images together at the appropriate percentages. So we could just do this with you and your mate and figure out what your child will look like using the correct percentage of ancestries.
So does the middle child have 4 eyes? Is that what I'm saying?
Yeah.
So this is an average child. This is like the
Yeah.
average child.
Yeah, the child with the most probability.
No recombination. Yeah, and so yeah, everything that we've said was built during this hackathon. None of this existed.
And these are all means that were generated by
Yes.
Yeah.
So we're going to show what we have live working. Cindy, take it away.
So who are those 2 anonymous bachelors luckily matched up with?
Yeah.
Random ones I picked.
So we built a really simple web application using Python Flask. There's no database involved. It's all kind of locally stored and passed around. Yeah, pandas. It's nothing fancy, but yeah. So first screen, you enter your name, or whatever name you want.
Greg.
So Greg. And you choose 23andMe data. So this is just the data that you get from your own account when you log in. Go to download raw data.
It's just a list of RSIDs and genotypes.
Then you click upload. And in the background, this runs Plink and converts this to BCF format. So now you are able to, oh, yeah. Yeah, so I'm, for the demo, I'm not comparing against all 1,000 genomes because it just takes longer. But yeah, I mean, you can exclude potential matches by various factors here. Okay. And then we click Find My Match, and it scores everything in the background, finds the appropriate avatars, and gives you some results, along with some hypothetical names. And it gives you some information about these potential matches here. So you can see that there's some variability here. Yeah, pretty much. Yeah.
So you have the description next to it also, so we know, that Charlotte has freckles, does not have a unibrow, has brown or black hair, and has a non-digital chin, and which is exactly what she looks like.
And this is their match score, if you're interested.
So what's the range of max score? Is it from like 0 to a million, or
How
can you
Yeah.
determine how good your match is, basically?
We didn't do
The
any
top,
yeah.
I mean, you could technically normalize it and scale it, but they're based on the magnitude of these good or bad SNPs. So we normally get it in 3000s, but you can scale it down.
So if you have more SNPs, your maximum will be bigger as well?
It depends, so you can have good or bad SNPs. So if you have bad, then it's gonna penalize your score.
Yeah, that's it.